1950, a physicist sat down for lunch with his colleagues at Los Alamos National Laboratory. His name was Enrico Fermi, one of the greatest scientific minds of the 20th century, a man who had helped build the first nuclear reactor, a man who did not ask stupid questions. Somewhere during that lunch, the conversation turned to UFOs and the possibility of intelligent life in the universe. And somewhere between the main course and dessert, Fermi put down his fork, looked up, and asked a question so simple it stopped the table cold. Where is everybody? That's it. 3 words. But those 3 words have haunted science ever since. Because the more you think about them, the more you run the numbers, the more you look at what we know about the universe, the more disturbing the question becomes. The universe is 13.8 billion years old. It contains 2 trillion galaxies. Our galaxy alone holds up to 400 billion stars, most of them with planets. The ingredients for life appeared throughout the cosmos. The conditions for it exist on potentially billions of worlds. And yet, silence. No signals, no visitors, no evidence, nothing. Where is everybody? Tonight, we are going to follow that question all the way to the edge of what science can answer. And what we find there is either deeply reassuring or the most terrifying thing you have ever heard. Get comfortable. Let your body settle. This is going to keep you thinking long after the lights go out. Part 1. The numbers that started everything. Before we can understand the paradox, we need to understand the scale of the problem. In 1961, an astronomer named Frank Drake wrote an equation on a blackboard. It was designed to estimate the number of technologically advanced civilizations in our galaxy that might be capable of communicating with us right now. The Drake equation. It became one of the most famous equations in science, not because it gave a precise answer, but because it forced us to think clearly about the question. It multiplied together a series of factors: the rate of star formation, the fraction of stars with planets, the fraction of those planets that could support life, the fraction where life actually develops, the fraction where life becomes intelligent, the fraction that develops technology, and how long those civilizations survive. Plug in conservative estimates and you get a handful of civilizations. Plug in optimistic ones and you get millions. Millions of intelligent civilizations in our galaxy alone, right now. And our galaxy is just one of 2 trillion. So where are they? Part 2. The Great Silence. Let's put some numbers on this silence. The Milky Way is roughly 100,000 light years across. A civilization that wanted to explore it, not at warp speed, not through science fiction, but using realistic technology, sending self-replicating probes that travel at just 1% of the speed of light, could colonize the entire galaxy in roughly 10 million years. 10 million years sounds enormous, but the galaxy is 13 billion years old. That means a civilization that arose just 10 million years before us, a blink of an eye in cosmic time, could already be everywhere. They would have had time to visit every star, every planet, every corner of the Milky Way, including ours. evidence. No megastructures around distant stars. No signals in the radio frequencies we've been scanning since 1960. No artifacts on the moon. No anomalies in our solar system that can't be explained by natural processes. The silence is not just absence, it is total. We have been listening for over 60 years, with increasingly powerful instruments, scanning millions of star systems, and we have heard nothing. Part 3. The wow signal. Almost nothing. On August 15th, 1977, an astronomer named Jerry Eman was working on a SETI project at Ohio State University, scanning the sky for radio signals from space using a telescope nicknamed Big Ear. He wasn't there that night. He was reviewing printouts the next day. And there it was. A signal. A strong, narrow-band radio signal that lasted 72 seconds and matched almost exactly what scientists had theorized an alien transmission might look like. It came from the direction of the constellation Sagittarius. It was so striking, so unexpected, so unlike anything natural that Eman circled it in red pen and wrote a single word in the margin. Wow. The signal has never been explained. It has never been detected again, despite dozens of attempts to find it with more powerful telescopes over nearly 50 years. It has never returned. Was it a natural phenomenon we don't understand? A reflection off space debris? A one-time transmission from a civilization that sent a single signal into the cosmos? We don't know. We still don't know. The WOW signal remains the strongest candidate for an extraterrestrial radio transmission ever detected. And it came once, lasted 72 seconds, and vanished. As if something was there and then wasn't. Part 4. The solutions. Scientists and philosophers have spent decades trying to explain the Fermi Paradox. The proposed solutions divide roughly into two camps. Either we are alone, or we are not, and something else explains the silence. Let's start with the explanations that don't require us to be alone. The zoo hypothesis. What if advanced civilizations know we are here and have simply decided not to contact us? What if they are watching, observing, waiting for us to reach a certain level of development before making contact? Like a nature reserve or a zoo. We do this ourselves. Anthropologists studying isolated tribes maintain strict non-contact policies to avoid disrupting their development. Perhaps the galaxy operates on the same principle. A great silence maintained not by absence, but by agreement. The sleeping giants hypothesis. What if advanced civilizations aren't exploring the galaxy at all, because they've turned inward, running extraordinarily complex simulations, experiencing realities we can't imagine, living out billions of subjective years in digital universes with no interest in the cold physical cosmos outside? Why cross the stars when you can create them? The signal problem. What if they are transmitting, but we're not listening on the right frequency? We have scanned radio waves, but the electromagnetic spectrum is vast. Perhaps advanced civilizations communicate using neutrinos or quantum entanglement, or methods we haven't discovered yet. We might be surrounded by signals and have no idea. Like a tribe in the Amazon rainforest, unaware of the radio waves passing through their bodies every second. Part 5. The Dark Solutions. Now for the explanations that are harder to sit with. The Great Filter. This is the one that keeps scientists up at night. The Great Filter is the idea that somewhere between simple chemistry and a spacefaring civilization, there is a step, an extraordinarily unlikely transition that almost nothing survives. A filter that most life gets stuck in. The question that determines everything is, where is the filter? If the filter is behind us, if the difficult step was something in our past, like the emergence of the first cell or the jump to complex multicellular life, then we may have already passed through it. We may be genuinely rare, perhaps unique, and the future could be open. But if the filter is ahead of us, then almost every civilization that has ever reached our stage has been destroyed before becoming spacefaring. By what? Nuclear war, climate catastrophe, engineered pandemics, artificial intelligence, some self-destruction mechanism that is nearly universal. In that scenario, the silence of the universe is not a mystery. It is a warning. It means civilizations like ours reach a certain point, a point perhaps not far from where we are now, and then they stop. Permanently. And the fact that we haven't heard from anyone else means the filter probably has a near-perfect success rate. Part 6. The Fermi Paradox and Rare Earth. There is another possible explanation that requires no filter, no silence, no self-destruction. What if complex life is simply extraordinarily rare? The rare Earth hypothesis argues that the conditions that produce life on Earth are not common. They are exceptional. A planet at exactly the right distance from exactly the right kind of star. A large moon to stabilize its axial tilt and prevent wild climate swings. A giant outer planet like Jupiter acting as a gravitational shield, deflecting asteroids that would otherwise sterilize the surface. A magnetic field strong enough to protect against radiation. Plate tectonics to recycle nutrients. An oxygen atmosphere. Every single one of these factors makes a difference, and the probability of all of them occurring together on the same planet at the same time may be extraordinarily small. Microbial life might be common, spread across the galaxy by panspermia as we explored in our last journey. But complex life, multicellular, intelligent, technological, may be so rare that in a galaxy of 400 billion stars, we are effectively alone. Not because life doesn't exist elsewhere, but because the path from microbe to civilization is so improbable that it has only happened once that we know of. Here. Part 7. What the telescopes are finding. In recent years, the search has intensified dramatically. The James Webb Space Telescope, launched in December 2021, is capable of analyzing the atmospheres of distant exoplanets in extraordinary detail. It looks for what scientists call biosignatures, chemical markers in a planet's atmosphere that could indicate biological activity. Oxygen, methane, ozone, the kinds of molecules that, on Earth, are produced and maintained almost entirely by living things. In 2023, Webb detected dimethyl sulfide in the atmosphere of a planet called K2-18b, a molecule that on Earth is produced exclusively by marine microorganisms. The announcement was cautious. Scientists were careful. They said more data was needed. They stressed the result was preliminary. But privately, among researchers who have spent careers searching, the excitement was real. K2-18b is roughly 120 light-years away. It is a type of planet called a Hycean world, potentially covered in a warm, shallow ocean beneath a hydrogen-rich atmosphere. If the dimethyl sulfide result holds up under further analysis, it would be the first evidence of life beyond Earth ever in all of human history. We are still waiting for confirmation. Part 8. The most disturbing possibility. Of all the proposed solutions to the Fermi Paradox, one stands out as the most psychologically difficult to accept. Not because it involves monsters or war or some external force that destroys civilizations, but because of what it would mean for us. Astronomer Robin Hansen, who formalized the Great Filter concept, pointed out something unsettling. The more signs of life we find elsewhere in the universe, the worse the news for humanity. Think about it this way. If we discover simple microbial life on Mars, or in the oceans of Europa, or in the atmosphere of Venus, that would be extraordinary, celebrated, historic. But it would also mean that life gets started relatively easily, that the early steps, chemistry becoming biology, are not the filter, which means the filter is somewhere ahead of us. The more life we find, the more common the early steps are, and the more the great filter must be located in our future, waiting. So when scientists celebrate the search for life elsewhere in the solar system, there is a shadow behind the excitement that most people don't see. Finding life nearby would be wonderful and terrifying. Closing, the question that defines us. So, where is everybody? We don't know. That is the honest answer. After 70 years of serious scientific inquiry, enormous telescopes, sophisticated signal processing, and some of the sharpest minds in human history applied to the problem, we don't know. They may be out there watching in silence. They may have turned inward to worlds of their own creation. They may be communicating in ways we haven't imagined. They may have passed through a filter we haven't found yet. Or they may simply not exist, and we may be, against all probability, the first civilization in the Milky Way to look up at the stars and ask, is anyone there? Consider what that would mean. If we are first, then the entire future of intelligence in this galaxy may depend on what we do next. Whether we survive our own technology, whether we become spacefaring, whether we spread life to worlds that have none. We would not be the children of a universe full of others. We would be the universe's first attempt at knowing itself. And everything that comes after Every civilization that ever arises in this galaxy would trace its origins back to this small blue planet, to this moment, to us. The silence of the universe might not be emptiness. It might be expectation. Whatever the answer, the question itself is one of the most profound our species has ever asked, because it forces us to think about what we are, where we fit, and what we owe to the future. The stars are patient, the universe is quiet, and somewhere out there, or perhaps nowhere at all, the answer is waiting. Rest now. Let the question sit with you gently, like starlight through a window. You don't need to solve it tonight. Nobody has. Good night.